Welcome to the video demo of Group 14's Map of Denmark. This program follows the popular software design pattern called Model View Controller. The model class keeps track of data at the core of the program, such as roads, addresses, and land uses. The view class handles all visual elements and retrieves information from the model. Lastly, the controller class handles user interaction and retrieves information from both the model and the view, acting as a mediator of change. With this in mind, let's continue. Upon initiation of the program, the user is met with a startup view containing two options, either selecting an OSM file to parse or loading from an embedded binary file. First, let's initiate the program by loading a select OSM file. For reference, an OSM file of Denmark contains approximately 153 million lines of text, which the OSM data parser class processes from start to end, handling specific tags and attributes such as nodes and ways. This information is delivered to their respective builder classes, which manipulate this data to retain only information that is strictly necessary for the program. The startup view will provide accurate real-time information about the current state of parsing, such that the user remains oriented. Once all elements in the file are parsed, the class will pass a primitive representation of the manipulated data to the model. This process includes building complex data structures, such as the address book and various KD trees, the latter being of particular importance, saving significant processing power. The program has now successfully parsed the OSM data and a map is displayed. Let's go over the other option in the startup view, loading from a binary file with the help of the binary decoder. The OSM data parser and the decoder perform the same tasks but with different sources. The binary source for the decoder is provided by our binary encoder class, which utilizes the serializable interface in Java on objects that are to be converted to the binary file. Serialization is the process of converting an object state into a byte stream, which captures all necessary information about the object to be able to reconstruct it. Upon clicking the Load with Binary button, the decoder will reconstruct the state of the model's objects and finally show the map view. At first glance, the user will be presented with 6 main UI components: the map, the sidebar, the indicators, the controls, the point of interest box, and the search bar. On the map, the user can zoom in and out by scrolling and pan by dragging. A different level of detail will show depending on the zoom level. The user can also click and create a point on the map. Upon creation of this point, a point of interest box will appear detailing the address, the coordinates, and whether it's close to any particular place like an airport or a bus stop. The user can rename the POI, assign it a tag, and then save it to the sidebar. In the sidebar, the saved POI will appear under the saved menu item. Clicking the icon will expand the sidebar to show its items. Similarly, the Reasons item will show any points and addresses the user has recently viewed. It's also possible to export the program view to a PDF file. Below the menu items, there are predefined locations on the map to which the map will move upon clicking. In the bottom right of the window, the user can view key numbers of the application, such as the amount of addresses and the current breakpoint level, amongst others. Above these numbers, the user will find the options. Here it's possible to zoom in and out, show a select rectangle of the map, change color mode, as well as select which elements to show or hide on the map. For example, enabling the KD tree will lessen the area of the KD tree viewport, clearly demonstrating the power of the data structure. Last but not least, there is the search bar. Here, the user can input a start and a goal address. The application will suggest autofill completions for addresses, as well as draw pins on the map for the suggested matches. If the user wishes to flip the addresses in the search, this is possible by clicking the reverse button between the search bars. Next, there is the option to choose what the means of transport is, and which pathfinding algorithm to use for the search. Clicking the route button will compute the route with the selected parameters. The computed route will appear with distance and time indicators. And as such concludes this video demonstration. Thank you for paying attention.